Hello everyone and welcome to this Genesys Customer Care Tech tutorial. Today we have Michael Cook from Voice Self-Service presenting Genesys Tech tutorial number 115 VHT 8.10 Troubleshooting and Integration. Also we have Ron Barton from Voice Self-Service with us to answer the chat questions during the session. There are a few logistics you should know before we get started. The tutorial will be recorded and posted to the Tech Tutorials page of the Customer Care website in a week. You will receive an email with a recording link when it is available. Phone lines will be muted until the Q&A session at the end of the presentation. If you need clarifications about the material during the session, you can type your question into the questions chat window and Ron will answer those questions unless a question would be better answered during the Q&A discussion at the end. Please be aware that we cannot address questions or issues about existing cases. When you exit the webinar, a brief survey will be displayed in your web browser. Thank you for taking a minute to complete the survey. Genesys uses this feedback to improve our tech tutorials. There are two windows, say Q&A and chat. We encourage the participants to post your questions and doubts in the Q&A window for us to monitor it better. With that, now I will turn the session over to Michael.
Thank you there. So my name is Michael Cook. I work in our voice self-service team here at Genesys Technical Support. The main focus for our tech tutorial today is to cover three main points, which are how Genesys integrates with virtual hold, our telephony integration points, and our GVP integration points, how inbound and outbound call flows work. We'll also cover a bit of log review, what typical Genesys logs are required to do any in-depth troubleshooting, and what logs are required for virtual hold, and and how you can increase or decrease those logs to get the information that you need. And finally, we'll cover a bit of troubleshooting, a few examples that I have there, or what to do if you're not offered virtual hold on inbound calls, what to do when there's no attached data on your callbacks, and things to look for when you're failing callbacks. Those seem to be the main issues that we see here at customer care. So the first part, as suggested, it's the Genesys and VHT integration overview. As a part of this, we'll cover that in a few sections. First, we'll cover the telephony portion, which is our SIP server, the required DN configuration for inbound and outbound call flows, our required SIP server options for URS, the required URS application options, required strategy configurations, and the required configurations in the virtual hold subroutines. The second portion of our integration is through our Genesys Voice platform. We require integration steps for our SSG, Resource Manager, and MCP. Part of SSG is some of the required application options. For Resource Manager, what logical resource groups are required. The configuring for your outbound IVR profile treatment. The integration of virtual hold directly. This is how to our switch and maintain holding. Part of that will also be the outbound IVR, how we integrate virtual holds outbound IVR with SSG, and certain virtual hold registry options that you need to set for VHT, GVP, and Genesys specifically. We'll also cover a bit of the Viz configuration with the later versions of VHT. We only supply they supply Viz VXML interaction server. They do have their own proprietary voice 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 service, but we won't cover that because it's actually provided by them, and it's not really something that Genesys gets involved with. The first part here is SIP server. So the required DNs for any Genesys or in VirtualHold integration is the trunk groups, and that's for our outbound. That's how SSG integrates with GVP to obtain its outbound ports, what ports it has available, and the specific or important option sets for those DNs are contact or contact list. That's how it's going to reach out to RM to facilitate the GVP call. The request URI, which is defined how we're going to append in the invite header to GVP, and the subscription ID, which tells SG which tenant those ports are available for. Also, we have the MSML VoIP service DN. This is important for our treatment requests because all inbound requests coming from VirtualHold are treatments. So the important configuration options there are the contact or contact lists, and that again is how we address the RM and get the calls into VirtualHold or into GVP, and the service type, which indicates what service that GVP needs to provide, which is generally the MSML service type. And other key DNs are the route point DN. That's where you will load your strategy, and which has also the VirtualHold subroutine embedded, and the virtual queues, which is how VirtualHold tile interface registers with Genesys so that it can receive attached data distribution. The main option that you'll see for just SIP server is making sure that your MSML support equals true. Otherwise, any treatment requests that come into SIP server won't be facilitated. So I'll give you a quick little overview of how those particular DNs should look. So we go into GA specifically for the trunk group DN. As you can see, it's type of trunk group, and here are the main options that we define. In my case, I'm using active-active RMs, so the contact just defaults to use the MSML's DN's contact list. But here's some other key requirements for the DN, which is, so we have CPA capabilities that indicates that our MCP is going to do the CPD detection for the outbound calls. Here's the request URI that was made mention before. This is going to be appended in the invite that comes from SIP server to RM to integrate with our GVP platform, and the subscription ID, which basically just says that this DN needs to register to or subscribe to the environment tenant and will facilitate the availability of outbound ports for that tenant. So here's an example of the MSML DN. As I suggested before, I'm using active-active. So in this case, our MSML DNs uses a contact list. This allows you to specify both your RM instances and SIP server round robins between these two interfaces as calls come in. Service type, of course, is MSML. So any treatment requests come in, this DN will facilitate that request. And as I said before, that's exactly how VirtualHold's inbound calls work. So here's an example of, as a route point, there's nothing really additional required for options in terms of what's added here, but as you can see, there's strategies loaded, and within that strategy, there will be the VirtualHold subroutine, which makes all the logic to determine if calls are going to be offered VirtualHold. And finally, here we have the virtual queue. Generally, they advise to define an alias here. And this is really just how these particular VQs are going to be pegged in your routing strategies, so that at the point where VirtualHold starts up, the tile interface registers to these particular virtual queues. And then anytime a call or router pegs these particular VQs, the distributed attached data will be sent over to VirtualHold so that it can ingest that for the call and store it so that it can be appended onto the call later on when the callback is made. So when the customer's callback happens, any business requirement data that's on that call will be available on the callback to make routing logic and reporting information available. So the second portion of the telephony side is URS. So because there's a requirement for URS to do a SOAP interaction with Virtual Hold's platform toolkit, you have to configure URS to be able to communicate over HTTP. So within URS, there's a few options here, which are the HTTP port, which is going to define the port that URS is going to open and use for any HTTP and SOAP requests that it sends off to Virtual Hold's platform toolkit. That's generally how we do our get offer decisions, whether or not we're going to be offered Virtual Hold, how we're going to get facilitate the actual inbound call flow rather than being sent off to the ACD queue. The HTTP log file, which allows you to generate its own log file so that you can track the SOAP requests that are going to Virtual Hold. Log file size, obviously, is just how big you want that files to get, and then the log remove old files is the expire. So however many log files it creates before it deletes old existing logs. The main crux of how the telephony integration works for Virtual Hold is the strategy configuration. So Virtual Hold provides a subroutine that you add to any traditional Virtual Hold strategy or URS strategy. They do provide ORS as well, but I've figured the basics were the best to cover here. So mainly what you would do is you would go in, you would create a subroutine block in your regular strategy. You would load your Virtual Hold subroutine, and then you would add some required priority and segments. So what the priority does, it defines that any callbacks that come in will have an increased level of priority, so that we're not prioritizing hold calls over callback calls, because the main desire for any callback is that it gets placed ahead of the line, so that the calls that are offered callback get to queue or get to the agent first before anybody that chooses to hold. And the segment portion is detailing our incoming extensions that you would have configured on the Virtual Hold end. So these would have to match so that when we do the SOAP action to Virtual Hold, that segment can confirm that we should be being offered Virtual Hold treatment. Second portion of the subroutine is there's a few default options that you must define, specifically the get offer decision URL. That's the URL that URS is going to use as a SOAP request to Platform Toolkit. That, if you can see it there, it's going to VHT platform WSV5. V5 came with the later 8.x versions. Used to be version 4, but now everything is moved over to version 5. Along with that is the tenant that matches the site ID that you configure when you install Virtual Hold. The VH segment is just a variable. The AVXML host, that would be the URL, the FQDN and port of your Viz host, so that wherever you have your Tomcat instance for Virtual Hold, that's the URL and port that you're going to define. And Viz is the root VXML name. That's basically when you extract the Viz application and dump it into your web apps folder of your Tomcat instance, that needs to match what the URL needs to define, because it actually appends itself to the treatment request that gets sent to SIP server to facilitate the inbound treatment. Excuse me. So we'll move on to voice platform. So the main thing, and we discussed this earlier in regards to the trunk group configure requirement for DNs. In SSG, the application requirement, you must define the trunk group DN that SSG is going to use. This is how it pulls the available outbound ports, and it does this via subscribe and notify events that go from SIP server to RM, which then come back to SSG to advise on the available ports. A few non-required, but virtual hold does do some recommendation on these options, which is the clean interval and sections, which is Genesys or VHT recommends this to be 15. Max attempt limits, virtual hold recommends this to be 1, and time to live minutes, that's 1. The time to live is also defined on how the trigger app on the outbound IVR is defined, which is also 60 seconds or 1 minute. So those match up. Generally, we want to have those match up because you don't want to have SSG timeout on the trigger request before the actual outbound IVR request from virtual hold times out. Excuse me. The next portion is Resource Manager. So every deployment of virtual hold will require an outbound logical resource group or a gateway logical resource group be created. This is how we facilitate our outbound dials. It's specific to each RM instance. So in the case of my environment, I have active RM, so I must have 2 gateway LRGs that point to both RMs that have SIP server as the resource. So if you see in the image below there, you can see and for RM1, you can see SIP server being assigned there with 5060 as a port and active redundancy. I've added a second one. There's no change to the assignment because it's the same SIP server that's involved in that gateway, but it facilitates RM knowing the IP address it's sending an invite to start a new session or new SIP session. Another key point in configuration for Resource Manager is the outbound IVR profile. This is what is going to be used to make the initial request to GVP to do CPD and play the outbound treatment. So unlike the inbound portion of virtual hold calls that use treatments, the outbound calls use the environment trunk group DN or your tenant trunk group DN. This is going to facilitate the execution of call party detection, as well as reaching out to Viz to play the outbound portion of your call. So some key options that you must define on your IVR profile is the service type, which is voice XML, the voice XML app module, which is fixed. It's VXML NG, which is our NG interpreter or new generation interpreter, which is almost all of our 8.5 forward configurations use this interpreter. Voice XML GVPI transfer option, SIP refer. This is specifically for how we transfer calls out of GVP. So bridge transfers or conference transfers generally keep MCP in the call path, whereas in these type of call flows, we want MCP to give the call back. It's not on router, so we want the call to get back into router so that they can determine that this is a callback and that we get the call back into queue and assign priority properly. The final one is the initial page URL. This is the actual request, the URI for your Viz outbound VXML. So the key important options that you must define here is the tenant, which is the VHT site name that you define at the start of installation. If that tenant name is not defined in the URL, the call will fail in Viz. You'll get an error when the call goes through on the outbound. It'll work on the inbound, but will fail in the outbound. So here's an example of how you would define that URL. HTTP://server would be the server name or FQDN of the Viz host and the port. The XML app, like I said before, that would be Viz or however you define the root web service. And then the rest is hard-coded as platform_support GVP outbound, and then you would define tenant equals, which is the tenant name or site name of your virtual hold install, in mode GVP 8. So here's an example from my lab. It shows how the IVR profile should be configured there. You can see the initial page URL and the service type. So another major, or I guess important configuration that you must define is the default application. Because all treatment requests for inbound calls for virtual hold use treatment requests to GBP, um, we must have default application defined on the tenant itself. If that's not defined, any requests that come in for treatment will go to RM and it will reject it because it can't find the logical resource group or can't find the IVR profile for the tenant. Defining that there, in my case, it's recording, but it could be just about anything because all it really requires is that MCP can fetch whatever it is that you're providing. An info event will come in later on to actually tell MCP what to play, but this just facilitates creating the session with virtual hold or with GVP. So moving on to virtual hold integration requirements. We talked a little, we brought up the switch configuration and how we connect to a switch type or how we define a switch type on virtual hold. Once you have installed virtual hold, there's a section which is the configuration or a icon which is a configuration wizard. And through this, you step through how you're going to configure virtual hold to integrate with Genesys. The first one, as you see here, is the site name. This would be pre-populated because it's defined at install time. The switch type is tile Genesys. This is telling the tile interface that it needs to speak to Genesys via TLib. And then the DLL name, which is PSDK, which is the typical protocol that we use or the language that we use to communicate with our applications. Next portion is the Genesys CTI server connection. This is where you're actually going to define how tile is going to communicate with your SIP server. So again, site name, which is pre-populated. T server switch name, that is the switch object that you create for any particular SIP server setup. And the host and port are the host name and default listening port of the SIP server application. So this would be the switch is the switch object that you create and assign to a particular SIP server or TIF server, and the host and port are the actual host and listening port of the SIP server app object. As you, another required configuration is the incoming extension. This is, if you remember in the previous slides where we were talking about routing, this is where you define the segments that we're going to pass to virtual hold to determine whether or not we should be offered virtual hold. So the incoming extension value, which is very important, this is what the SOAP request will match on. So in my case, it's 600 or 6100. When a SOAP request comes from URS to virtual hold, it will have this as a value, and virtual hold will then use this value to determine whether or not it's available to be offered virtual hold. The label is this is arbitrary. It's really just for a naming convention. The country ID lists the phone number rules that virtual hold is going to use. So in my case, it's North America, so that's set to 1. Treatment type is very important for viz integrations. It must always be set to 20, or PSDK, I guess is or PTK, sorry, platform toolkit. That's the that's the value for that form of integration. As well, there's holding queues, callback queues, and under threshold queues. You would also go through as a part of these configurations to define those queues, and that's how you're going to identify what specific queues that particular extension or segment is going to relate to. So in this case, I have VHT test because the only queue that I have is my VHT test queue. So any calls that come in for this particular extension will always match these particular queue IDs. Another main integration point is the virtual hold's outbound IVR. Outbound IVR is facilitated through specific .xml files within the VHT install directory. In our case, because it's Genesys, we're using outbound IVR underscore SSG. This is where you define the specific connection requirements and connection sets for communicating with the SSG. SSG has configured HTTP listening port where it will get HTTP requests directly from the outbound IVR that Virtual Hold provides. That will come as a post request from VHT to SSG with a specific token number. When we result in success, that comes back to Virtual Hold, and it determines that that callback, at least from a VHT outbound IVR perspective, has been successful, and we'll wait for additional parameters or additional requests that come through. So a couple of the main options that are defined in the outbound SSG are the default ID. This defines the identifier of the connection set. So with this configuration, you can add multiple connection sets, which will allow you to communicate with multiple SSG instances on the Genesys side. So if you have 2 or 3 SSGs that could be used as a high availability option, you can define failover connection sets so that if one fails, or if you don't want to, or if you want to distribute the load between your SSG instances, you can have your configuration move between those connection sets as new requests come through for callbacks. The number of connection sets, which are the total number of connection sets that you've configured, and then the specific connection set parameters. So that would be URI, which is the host and port of SSG. The ANI, that's the number that you want to have displayed to the caller or to the customer when the callback is made. Maybe you want to have that as your 1-800 number for your business or what have you. The tenant name, that's the specific Genesys tenant name. Also the trunk group that SSG is using to facilitate the outbound ports. The IVR profile name, which in our case is the outbound IVR profile that we talked about previously. This is basically just the IVR profile that should be used when engaging GVP. The notification URL, this is basically just defining where SSG should send responses back to when we get results for things like call party detection. So as long as we get I think the focus is getting the result of human. Once it receives that result, it considers that a success and can move on with the additional processing of the call. In the event that we get something back like a fax or an answer machine, Virtual Hold has different ways of processing that result. So the next option is next connection on success. This determines that if it's going to use another subset of connection sets in the event that the first one is successful. So this is more for how you are going to configure load balancing between your SSG instances. And then the next connection on failure determines how it's going to handle a failure. So if the first connection fails, it tells it to move on to the other one in hopes that you can provide some high availability for your SSG instances. So here's an example from my lab here, just some of the key points we're talking about. So the default ID here is the VHT test, which just matches my my test environment and how I've designated things here. The number of connection sets is 1 because I only have one connection set defined. So you can see here connection 1, where you've defined all the parameters. If I was to have multiple ones, it would be connection 1, connection 2, connection 3, and then I would define the total number of connection sets that I have in that number of connections parameter. So here you see the URI. That's the host name and port. The default port for SSG is 9800, and the folder name SSG. So this becomes pretty standard, really in most cases, unless you've updated anything on SSG to listen on a different port. It's just going to be the host name of your SSG instance or the IP address of the host that serves your SSG instance. Here you see ANI. So in my case, any callbacks that I get will have a callback or a call party name of 800-555-5555. Under tenant name here, you see its environment because I'm running a multi-tenant environment. So That's the default tenant name for my environment. IVR profile name, VHT underscore outbound, and that matches the configuration that I have in my IVR profiles under the Genesys Voice Platform section in GA. So here's the notification URL. This is where you're going to define the actual IAS instance that's handling your callback responses. So in here it would be wherever you've deployed your IAS instances for VHT. That would be your platform toolkit, web responses, that kind of thing. So under here you see a time to live. That's when I was referring to the time to live configuration in SSG settings being 1 minute. Here's the same thing. So when that trigger request comes through to SSG, it's going to give a 60-second timeout before it will consider that request that was sent from virtual hold a failure if it doesn't receive an accurate response for call party detection. In that case, VHT then marks that as a failure and then sets it for a retry within however many seconds. Here you see also detect voice AM. So voice would be the human equivalent for virtual hold, and AM would be answering machine. So the next section here you see connection on success. Because I only have one connection, it always goes to connection 1, which matches the connection name here. But if I had multiple instances, it would be connection 2 or connection 3, however you want to configure your environment or however many instances of SSG you may have. And then the next connection on failure, which basically does the same thing. In the event of a failure, it will move on to another connection set. So next is the GVP toolkit properties. This file is provided in the Viz deployment that you download from Virtual Hold, or is provided through Genesys when you purchase Genesys, or when you purchase Virtual Hold through Genesys. This properties file must be updated and stored on the Viz server that's hosting your Virtual Hold VXML. This basically gives base information for the Viz server to use as a part of its logic when it's getting callback information. So the main options that you would set here are the base URL. That's the URL for the platform toolkit. It's similar to what you define in the router for your get offer decision URL. It's basically the same web service, but it would just be different components that serve that up. External media server. This is going to be where you configure your voices. Generally, this is just going to be pointing to the Tomcat instance that you have deployed with Viz, and then the folder of voices that you're provided. So Virtual Hold provides a folder of voices that gives you multiple languages that provide the same verbiage for all of their callbacks. So when the IVR is being played, they have certain prompts that they play back. They have certain things. Customers can have that customized, but that all has to go through Virtual Hold directly. Otherwise, you just have these standard prompts that get provided when the playback is being made, and as long as the voices match the language that's configured in Virtual Hold. So we have the Virtual Hold Toolkit web audio path. This is the path to the ASAP and schedule callback names for files for playback. That's typically just a route. We generally, when the outbound IVR or the inbound IVR is played, it's asking you to speak your name so that it can be played back to you when you call back, so that it can confirm that the person that requested the callback is indeed the person that received the callback and they can play their name, and those audio files are available. That can be changed depending on where you want to have those particular callback names stored. Generally, the default is under the root install directory for Tomcat. The Virtual Toolkit defaults destination. This is basically telling Viz, in the event that it can't talk to Platform Toolkit, where it needs to route the call. So the call just doesn't die because of the way outbound calls are made. They go directly into GVP. They don't go through router or anything. So anytime if the call isn't transferred out of the VXML or out of the IVR, the call will be killed or will be tore down. So customers would like to be able to at least have the option to be routed back into queue or into a holding queue or something to handle any particular failures of communication to VHT's platform toolkit. So these are both for inbound and outbound configurations. The first one, default destinations for inbound, and the default destination or outbound default destination is for the outbound configuration. And these would be specific route points that you have configured on your Genesys SIP switch. So that's the main integration points that Genesys has with Virtual Hold and what Virtual Hold has set up for communicating with Genesys. Like I said, inbound requests are quite different in terms of how they engage SIP server and GVP to facilitate the treatments versus how outbound calls are made. That one is URS centric and the one is DID or IVR centric. So those are key portions that you want to keep in mind when you're dealing with the call flows for Virtual Hold. So the second part of this presentation is going to be logging review. The main focus that we're going to have here is what logs would be required from Genesys and what logs will be required from Virtual Hold when you're opening up a case with customer care or through support with Virtual Hold directly. There's some key things that we look for, things that you can use to assist in your troubleshooting of the problem. So some Genesys required logs for SIP server. We have some specific call identifiers, tile registration events in the SIP server log, and specific attached data. For URS, similar, we have specific call identifiers and the SOAP action. That's where we see the get offer decision, and that tells us whether or not router is able to talk to Virtual Hold and pull back whether or not we're going to be offering Virtual Hold to that caller. SSG has a set of call identifiers that you normally look for, and the event resource info, which tells SSG how many available outbound ports are available to it to use. If that becomes 0, then SSG just won't make the outbound call, and your callbacks will start failing. For resource manager, there's many call identifiers that are very similar to SIP server. We have call IDs and the like, but the main things that you look for in terms of callbacks specifically would be your subscribes and notifies. So SIP server sends a subscribe to RM, and RM responds back to that subscribe message with a notify event, which tells it how many available ports it has. We'll be covering the requirements for MCP, which is tracking how CPD is set up, making sure that MCP is able to successfully fetch the VXML pages for the IVR, and we're appropriately doing refer transfers out of MCP once the callback has been completed. Some required logs for Virtual Hold we'll be covering as well. We'll cover some of the VHT core logging, which is, we'll cover where a lot of the Virtual Hold default logs are located, how we increase the verbosity of that logging, and what important log sets or what log sets you would want to look for certain things and to troubleshoot your issues, as well as viz logging. So that would be default log location and log4j rolling. So the first part is SIP server. So the main call identifiers in SIP server are con ID, UUID, and call ID. If you're familiar with Genesys, you already know how these are used mostly. You'll see them on day-to-day efforts trying to investigate calls, but con IDs identify a single interaction with SIP server. That is susceptible to change when a call is transferred. The UUID identifies the entire life of a particular interaction with SIP server. So one UUID could have many con IDs or call IDs associated to it, but it's basically the thing that stays persistent throughout the life of a call. And the call ID identifies any SIP interactions either through GVP or to a gateway or to some agent's desk phone. That's how we facilitate moving calls from one end of your Genesys environment to the other. So here you have some examples of where you would find these. So here you have an event call created, which has your con ID and your UUID. And here's an example of an MSML request that would go to GVP. Here you can see the call ID, and you can see a matching UUID. You would use these in tandem with each other to troubleshoot call flow issues or anything like that that go between SIP server and GVP. Another important aspect of the logging is our tile registration. So like I said previously, Virtual Hold has a tile interface which communicates to SIP server directly using TLib. So when the tile component starts up on Virtual Hold, it sends a register request to SIP server where we've defined it in the configuration. It will do a registration request on this VHT INTF app name. So now anytime that that particular queue is pegged, the VHT interface will be a part of the distributed call. So here you see the application name register as a client to SIP server, and here you see the DN that it's registering with, VHT_test, and you get a confirmation that that interface has registered to SIP server, and that's what you're going to look for when calls go through. When we start doing request update data and event distribute attached data, you're gonna want to make sure that VHT INTF is a part of the distributed clients that are getting those events, much like you would see for Stat Server or Icon or anything like that. You'd want to make sure that those TLib events are going out to Virtual Hold as well. And if they aren't, then you're not going to have attached data on your callbacks. So here's an example of some attached data. The main points that you want to see for attached data with Virtual Hold is the VH transfer destination. This is basically going to tell you where you want to move the call, what route point you want to move the call to on your callbacks. And if we don't have that bit of attached data, when the call comes through, MCP is not going to know where to transfer the call back into queue to determine that it's a callback. So that's where we ingest that as a part of the inbound flow so that your outbound IVR can use it to get the call back into router when the callback's made. The next one is the VH offer. So as a part of I was talking earlier about the get offer decision that URS makes to the platform toolkit. We offer the segment of an incoming extension, and then when a Virtual Hold determines that we should be offered Virtual Hold, you'll see this VH offer _yes or _no. Yes means that we will be offered a treatment for Virtual Hold, and no means that the call will just move on and to the ACD queue that's defined. So also here in the bottom, you can see the attached data that's being distributed. So we see that we're distributing events out, and the VHT INTF is receiving or is a part of that distributed event. So it should be receiving this bit of TLib as a part of the call flow. So next is URS. URS has similar call identifiers as con ID, call UUID. This can be used to track the calls through your logs to make sure that SIP server and URS have matching logs, and now you can identify the issues of that call in both those sets of logs. So you can see here we have an acute event that comes from SIP server with a matching call ID and UUID. So I talked a bit about the SOAP action already, but here is an example of the get offer decision or the SOAP request that's sent from Virtual Hold or sent from URS to Virtual Hold to determine if a call should be offered treatment. So here you see the SOAP request go out. The method is get offer decision. You can see the URL where URS is sending that request to the platform toolkit. And then you can see under input, you can see the tenant name, which is the site name for Virtual Hold, VHT, and then the segment name, which is the incoming extension that that call has that needs to determine whether or not that call can be offered virtual hold. So that's the SOAP request that goes out, and just below it, you'll see the response that we get back from hold or from IIS. You can see here that we get a string of value of Y. We interpret that as V1Y or 1:Y, and then we get a request update user data with a VHT for _1:Y. So a router will take that logic and determine that we need to offer a treatment request to GVP so that GVP can reach out to Viz to play the inbound IVR. So now that we've done a bit of the inbound logging for SIP and URS, now we'll talk a bit about the GVP integration with outbound. So for SSG, the main call identifiers that you want to look at in SSG for outbound calls are tokens. This identifies a successful request that comes from VirtualHold's outbound IVR. You'll see a token here that was made mention. Once we get that token is appended to all attached data for that outbound call. And once we get that, you'll see a request make predictive call. That request make predictive call is sent to SIP server to initiate the callback sequence. So here you'll see we attach the SSG token, we attach the outbound IVR variables. That would be the callback number, so where we want the outbound call to be made, the queue that the call was made for, VHT test, and then whether or not this is an initial call or a tryback. So in some cases, you'll have a callback fail either because the customer didn't answer or because there was some type of failure or the call didn't complete in GVP. Any number of reasons that we don't get a successful CPD result or a successful callback where a customer goes into the IVR and is able to determine whether or not their callback was successful, either by moving on to queue or for canceling the callback. A new trigger request will come back and it will be a try again callback instead of a FIFO callback. We also made mention of the event resource info. This is the events in the SSG logs that you're going to want to look for to make sure that SSG has available outbound ports to facilitate callbacks. As callbacks are made, this available ports number will decrease as callbacks are used. Once those ports should be relinquished back into available ports once the call is completed. In the event of a problem or issues, there has been occasions where RM loses track of available ports or is no longer sending notify events of the available ports. That number will continuously go down to 0 once that available ports hit 0. SSG will no longer be able to send outbound calls or facilitate callbacks. And then you'll want to look for that event in the logs to make sure that SSG is even able to make those callbacks. So I talked a bit about the subscribe and notifies that RM uses, but here's what facilitates the actual status of media services. So we'll see a subscribe event that'll come from SIP server to RM. RM will then get that and determine however MCPs are online to facilitate a call, and then there'll be another subscribe request that will give a total port count. So if in the event that a subscribe event comes back and we respond back with no available media servers, then any SIP requests that come to RM will get a 480 and available. And any time that we get a port count that's 0, then we'll send an update of 0 to SSG, and SSG won't be able to facilitate the callbacks. So here's an example of the notifies that I was talking about. So once SIP server gets the subscribe, for this case or this top example, you'll see Genesys media server status, and then below that you can see the number of media servers that are in service or out of service, depending on however MCPs that you have deployed. In my case, I have 1 in service and I have 3 out of service. One is for SSL, but basically I have one active MCP that can handle any treatment requests or any calls that come in for media treatment. And then a second subscribe, as I talked about, which is the tenant ports. So once RM receives that subscribe for tenant ports, it will update SIP server with a notify event with the available ports. In this case, it's 100, 100. So it's going to offer up back to SSG the event resource info will have 100 out of 100 available ports. So moving on to MCP, as I said, MCP is responsible for doing the call party detection, or basically determining that a human has picked up the phone when the callback is made. So that is a crucial point to how callbacks are done, because if the initial setup of the call isn't made to MCP, or MCP can't talk to some VXML application to set up the session, the outbound dial won't actually happen. So it'll get to the point where it engages MCP, makes MCP ready to start a session. If MCP is not ready to start a session, then the call back to the desired contact number won't happen. The timeout will throw, and then you'll get a try again trigger request from virtual holds outbound IVR. So in this case, when you're looking through MCP, you're going to be looking for this post-connect event. Pre-connect is generally used for sit tones or or carrier-specific tones that happen before a call is actually made, or an RTP session is established with the customer. So we mainly focus on the post-connect event. That's once a session's been established with the customer's end, the call's made it, and the far end is picked up. And then we're looking for the CPD result. So the CPD result is human. That is considered a successful call party detection, and the SSG will then advise virtual hold that outbound call has been successful, and the call will move on to the outbound IVR. So I talked a bit about the page fetch. So for treatment requests and for the first setup of the outbound IVR for CPD, we're going to get an initial page URL that we need to fetch to set up the session. When you're looking at MCP logs, it's important to make sure that fetch was successful, or else the session won't set up, or you'll get dead air on the call if we're doing a treatment request, because if we can't fetch the VXML, it'll basically error out, or it'll fail, or that portion will fail. So that could fail either on the inbound or outbound. So you're going to look for key parts of the logs. You're going to look for the actual URL that's being specified for MCP to fetch, and that URL is an HTTP request. So it'll be a GET request that goes out to a web service, and we'll expect a 200K result. Here you can see in the below example, you can see the GET request. And then you can see below that we have a successful file fetch succeeded, which now we can progress on and move on with the outbound IVR or the inbound treatment request, depending on which part of the call flow you're in. The next part is that once the callback has been made, once you go through and confirm that you are the person that requested the callback, and you select one and you want to continue on, MCP gets a bunch of the attached data attached back to the call, and then we use the VH transfer destination value that was ingested on the first portion of the call, and we use that to facilitate the transfer out of GVP. So you're going to want to look for the actual refer event. You want to make sure that the DN that's used is the appropriate DN that the callback should be made on, and that transfer request will be sent to generally sent over to router so we can determine that it's a callback being made. The disposition is callback, and the call needs to be added priority and put ahead of all your holding calls. If this doesn't happen, or the refer doesn't happen, or transfer doesn't happen, the callback will be made, but the customer won't end up in queue. If this transfer fails, basically the customer will get hung up on, and the call will get cleared from the system. So you want to make sure that anytime that the callback once the callback's done in the outbound IVR, that's getting transferred back into your strategy that the VHT subroutine is loaded on. So we'll move on to the required logs for virtual hold. So virtual hold has a bit of a different way that it handles its logging. So it stores logs in two places. One is the archive section, and one is the log section. So the archive folder is used for any time that logs have reached a certain period of time or reached a certain size. They have an archive service that goes through and compresses all of those log files and then stores them as 7Z files in the archives folder. So anytime that you're looking to troubleshoot a problem that happened a day ago, you're going to want to make sure you're looking in the archive directory for the timestamps, because it's going to show you what VHT logs have been archived since and have been stored there. Because if you only provide what's in the virtual hold logs, you're not going to have the sufficient information, because the logs are always rolling, are always being archived by that service. And the key point to know is that generally virtual hold only keeps logs for 7 days. So anytime that those logs reach that 7-day point, usually get flushed out and are reprocessed. The second place is VH logs. That's where the active logs are being written to and stored before they're being archived. So another key thing to note when you're looking at VHT logs is that the timestamp on these folders are based on the time that the particular application has started. So in this event, that you could have logs that are in the 27th of October, and then you'll have another set of logs that have rolled over and have moved into the 28th or have been restarted, or components have changed or anything like that, and then it'll create a new folder for the 28th. So you'll want to, generally when Genesys is asking for provided logs, we just ask for the entire directory here, so that we're making sure that you're not missing out on the logs, because the logs that we're looking for may be on the 27th, even though the issue happened on the 29th, but the application just hasn't restarted, or nothing's changed to make that log move to the new October 29th folder, for example. So generally what we will ask for customer care is we'll ask for the entire directory of logs here, and then we'll ask for any of the archive logs that cover the timestamp that the time of day. So if it happened on the 28th, we want any archives from the 28th, or at least a few hours that cover that time frame. So the virtual hold logs can be configured. To configure those logs, you go into the virtual hold registry. It's under HKey local machine software WOW 6432 node virtual hold. You can modify the location of the log files to move them to a different path, and you can also change the verbosity. Virtual hold generally recommends that you leave it at 5, because it has enough information that you can do troubleshooting, but not too much that you're overlogging or putting too much information in the logs to make them hard to read. Generally, you won't have virtual hold ask you to increase that unless you're looking for development related information, where you're going to have to send that off to engineering and they're going to get that information. So the main sections that you'll want to consider are the log path and the log level. So they separate them out based on the individual components. So you can see there's IVR log path, and that's specifically for the IVR component. There's the QWatch client log path, that's for QWatch. There's the main log, that's for your main logs, that's holding all of your relevant call processing. The report log path, so wherever reporting servers writing logs, tile, where tile logs should be stored, and it goes on like that. Generally, these options require a restart of the service once these registry changes have been made. So generally we don't, unless you're advised to change these, usually we just ask you to leave them as default. Some of the main important log sets that we would ask, or that we look for in VHT, are the main, tile, and IVR. So the main output logs, that's basically the entire life of processing of any call, and that's for both inbound and outbound. So when a call comes into virtual hold through an outbound process, the main output log is going to walk through the steps of processing that inbound call, the get offer decision, the ingesting of attached data, and the storing of the call for callbacks later. You'll also see when the callback is being launched, you'll see in the main output log that the call is being launched, and then all the additional processing that happens to the call after the outbound call is being made. The main report log is good to use for a high level idea. So sometimes you'll have examples of some failures that happen for particular calls. That's a good, easy way of seeing an overall idea of how many calls went through the system, and then get a brief description of what happened. Either the call failed to transfer, or the callback wasn't able to launch, or something. It's a quick, easy way of identifying any particular problems, and then you would use the main output log to dig into what actually happened. The tile, that is for all your TLib events. So you'll want to use that to make sure that attached data is being sent over. You want to make sure it also will determine whether or not you have an active connection with SIP server. If we disconnect, you'll see errors in the logs. They'll determine that, oh, well, tile's disconnected from SIP server, so it won't be getting attached data. So all your callbacks will be missing any of the attached data that should have been on that call. And then the IVR outbound log, that's used for all logging the triggering app before any of your VHT callbacks. So you'll look in that log to make sure that, oh, well, if somebody complains that callbacks are failing, you can look in that log to make sure, well, I can see that virtual hold at least got a successful callback launch to SSG, and then you can move on from there. If the callback doesn't leave the outbound IVR, it hasn't even gotten to Genesys yet, so then you can start looking specifically on why maybe the outbound IVR isn't functioning. Is there a misconfiguration in the SSG connection, or in the IPR or the outbound IVR underscore SSG XML? Any number of things. So those are the key places that you want to look for problematic issues in virtual hold, or when investigating problems. So from there, we'll move on to a few troubleshooting topics here. We'll just go through a few key things that I generally see on a per cases basis, where either calls aren't being offered, or calls don't have attached data on callbacks, or callbacks are actually failing. So some points of interest. In the event that we have no offers on inbound calls, you'd want to be collecting SIP server logs to validate that we have attached data. You want to take a look at URS logs to make sure that the get offer decision is being sent to virtual hold to determine whether or not the callback should be offered. And then you'll look in these, you can actually do queries against the platform toolkit web service to determine what valid segments are available, and whether or not you can do a manual query against the get offer decision web service to determine if that web service should have offered virtual hold. So you can see in the example on the top there, you can see in this case virtual hold wasn't offered. It was given a no response. So in that case, URS would just send that to the ACD queue. In the below, excuse me, in the below instance here, you can see it's just a standard REST API where I'm calling the web service with a particular fetching of segments, and then in the below option, you can see those segments being addressed. You can see the tenant name, virtual hold, the queue that I've assigned to that segment, and the actual segment name, and that should match your incoming extension values in virtual hold's configuration. So I can give you a bit of an example here. So in here you can see the queue is VHT tests. and segment is 6100. And if I was to want to do a validation test on that segment, let's say we're getting an offer of no or no calls are coming in, you can use something like the Virtual Hold has an internal get offer decision where you can go right on the IAS page, or you can use a standard request API or a excuse me, a request API to do those requests or do those queries. Excuse me. So here you can see it's a post which goes to the Virtual Hold web service. The function, if you want to look at the body, the function is a get offer decision. And then you specify the tenant and the segment name. And in this case, I get a yes. If this was incorrect, let's say somebody misconfigured the segment in the router and then sent that, you'd get a no. And a way to validate the actual active or valid segments that are in Virtual Hold, you can do a get segments request. Here you would define the tenant, which is just going to say, what segments do I have available for this tenant? And it will give you a list of available segments. So you could go back into your routing strategy, for example. And you look here, and if this was configured as 6102, and when that call comes in, the get offer decision is going to go out to Platform Toolkit, and it's going to get a no. So you could go back in here, update your strategy to add the valid VH segment, and then the next request that goes through will have a successful or will give you a yes response. Another aspect or another common issue that we see is no attached data on callbacks. The point of interest for these would be SIP server, making sure that we have attached data on the calls, making sure that VHT's interface is being distributed to tile so that we're getting events, making sure, pulling URS logs, making sure that we're pegging the VQ. If you see in this instance above, in this case, you would expect the VQ to be pegged in this call flow, but it's not. So we can see the get offer decision is still valid because we're still sending a valid segment, but any of the attached data that may be on this call is not going to Virtual Hold. So when the callback happens, there won't be any attached data on it. Another thing would be to focus on is to make sure that tile is actually connected. So here's an example in the tile logs where you can see a valid connection where tile is reaching out to SIP server. There's the host, and there's the listening port, and there's the application name that it's looking for. We also have a keep alive component where you'll see tile will be sending constant basically pings out to SIP server to make sure that it has an active connection to it. Once that timeout has been thrown on a keep alive, then you'll see a failure to connect in the tile logs, and you can do some investigations, either network or maybe tile needs to be restarted, or there's something blocking that information. So in this case here would be an example where attached data should be working. So in my case before, in the image that you see before, there was no attached data going to VHT_test. So that means that Virtual Hold was not pegging, or URS was not pegging that particular VQ. So in this occasion, it's a little bit messy, but this is the easiest way to make sure that you're pegging a VQ. Here's the main strategy that comes in. In here, I have a target block. Here, I'll give you a better example. here's an appropriate setup. So we have a target that's going to a VQ name. The virtual queue is assigned as an alias of VHT underscore test. The SIP switch where that VQ is installed on, and then the actual DN number. So you need to make sure that that particular VQ is being pegged as a part of your strategy. There's many ways that you can deploy that in your strategies, but this is one of the simpler ways to do it. In my case, if no attached, where you see the attached data is not being provided, it's because the alias that I've used is not a valid VQ. So in here, there is no such thing as VHT underscore test underscore one that's deployed on SIP server. So then you would just update this guy to use a valid VQ. And then on the next call that comes into that strategy, we'll peg the VQ as it's expected to, and you'll see this being distributed. And then as you go down through looking at your router logs, you'll see that here, try to find the distributed event where tile's getting. So here you can see the VHT interface is getting it on that particular VQ. So now we know that any of this attached data is going to be added to the callback when the callback is made. So another main thing that we look for, or a lot of times are issues that we get for, or cases that we get for virtual, or the callbacks are failing. Excuse me. There's a few key points of interest there. First one being the outbound IVR. As I suggested before, we need to make sure that the outbound IVR is actively sending the trigger request to virtual hold or to SSG, and that the make callback is happening. So here you can see an example of where outbound IVR is logging that it's sending a request to VHT underscore test, which is the default ID for my outbound IVR underscore SSG XML. Here you can see sending to the call, define the callback response, and here you can see the successful SSG token that's generated. So like I said, that will be appended to all attached data for that call moving forward. You just want to make sure that we're getting a successful request there. Another thing you're going to want to look at from SSG, you're going to want to be able to match that success token in the SSG logs. We already covered going over making sure that the event info is providing available ports, and making sure that the request make predictive call is leaving SSG and going to SIP server. Once we validated that the request make predictive call has gone to SIP server, then we want to go and look at SIP server logs to validate, did it get the make predictive call request? Did it set up the invite for GVP to establish CPD? Once CPD session was set up correctly, did the outbound invite to the customer happen? Once that happens, did we get a CPD result as human? And then once that happened, did the call move on to the outbound IVR? Here, you'll also be wanting to look at validate the CPD result, and also validating that we've reached out to Viz and got the initial page for your outbound Viz. Another portion of the troubleshooting is that sometimes the outbound call will be made, but then you'll get some type of treatment back that's saying that the callback system is being shut down, or something to that effect. And generally, that's because something in the data that's being passed to Viz server is invalid. I talked to you before in regards to the outbound IVR configuration. So in this string, I made mention that the tenant IVR or the tenant value had to match the site name. in my example here as a test, I made an incorrect value here on the tenant name. So when that tenant name gets passed to Viz, it will actually return back this error that you see here, which is invalid tenant name. So at that point, you can go back and look at your outbound IVR string and then change the string back to the correct site name. Now that once you save that, the next call that goes through will be able to match that outbound IVR name correctly, and the call will go to the appropriate outbound IVR. That's more. That's most of the troubleshooting steps that I was going to cover and the integration I was going to cover. I'm sure that a few of you have questions and stuff, but before we start question and answer, I'd like to mention that there's a few other resources that are available to customers and partners. We have the Genesys University. It offers troubleshooting workshops that can increase your understanding of Genesys products and solutions. For more details, you can go to our Genesys University website listed there, genesys.com services, Genesys University. You can visit the Genesys knowledge base to access a variety of information about Genesys products. Our customer care puts together anytime we have issues that aren't specifically related to server application specific things, like maybe some solution articles or things, known issues that we may come across that don't fit well in our actual guides. You can see a lot of those things there, like product advisories, answers to technical questions, manuals, and that kind of thing. Our next tutorial will be presented by our telephony and reporting team, and our reporting and analytics teams. They're expected to be held next year. The first one by telephony team in January, and the reporting and analytics team are hoping to have another one in February.
Thank you, Michael. Now let's start our Q&A session. Participants, please click the hand icon on the meeting screen and your phone lines will be unmuted. You can also type a question in the Q&A window. You can find the hand icon next to your name in the attendees tab.
I see somebody had asked something in the chat there.
Okay.
I think I see it here is VHT preferred over Genesys callback in terms of license costs and integration? That's something that you're probably going to want to speak to your Genesys representative and sales people. We don't give any type of here. We don't deal much with in terms of cost or license costing, that kind of thing. That's more something that you'd want to discuss with people that are planning out your talking to the sales team and making sure that either are giving you appropriate service that matches what your business needs. I'm not sure I understand. The next question is, can we provide any callback number under VHT? I think you mean, can we define any? The callback number will be what you're asked to define. So there's two options within Virtual Hold. There's an option to set it to record the ANI of the inbound call, and that will be stored as in the memory of Virtual Hold to use that number, so you don't actually have to specify your callback number when you're requesting a callback. It will just use the ANI value that was passed in when the callback came in. Or if you don't set that option, then there's a prompt that asks the customer to input the number that they want to be called back on. So once you input that, that's saved in memory, and then when the callback is launched, it will go to that one. So there's a question here, which is, what are the impacts of if the tile monitoring stops monitoring the queues? Is there a default plan? So in the case where tile stops monitoring the queues, there's no integration point for virtual hold to obtain any of the processing that router or SIP server is doing outside of the TLib events that are being distributed from SIP server to tile. So in the event that if tile is not being pegged, so it's not necessarily monitoring. So if tile disconnects, it can't monitor. But if the URS strategy is no longer sending or pegging the VQ, it won't be getting that distributed events either. So in both cases, there's no way to get that data over to virtual hold to process. So there's no default behavior other than your callbacks will have no attached data associated to them. There's another question here. Is it possible to have multiple Viz servers for redundancy at the same location or a multi-location setup? I believe with the dawn of the 8 release, that we do support multiple Viz instances. That any configuration you'd have to go and take a look at the installation guides, but I do believe that we offer redundancy for Viz servers and shared voice locations.
I suppose there are no more questions. Now you will see a poll window in your screen. We shall wait for 1 minute until all the participants complete the survey. Thank you for taking a moment to complete this brief survey, as your feedback really does help us improve our tech tutorial programs. Thank you, Michael and Ron, for sharing this information. Thank you everyone for attending. We look forward to seeing you on our next tech tutorial. This concludes today's webinar.